Thank you, Detlef, for your kind introduction. Good morning. I'm happy to be here and to be invited. I'll show you in the next 20 minutes the work we've done within the IEA, mainly on focus of solar energy forecasting. Okay, here are the contents. So I will show very quickly the background of Metatest, the company where I'm working at, and the IEA. Then I'll show you the results of the last task dealing with solar forecast of the IEA, and then I'm showing you the work plan of the new task. We just started with it, so there are no big results yet, but there are 2 points I will show about the metrics, how to measure forecasts, and what are the value forecasts, probabilistic forecasts, and regional upscaling, some work we want to go into detail. Metatest is a private company founded in 1981. It's an independent company located in Bern in Switzerland. We are about 35 people. We are provider of meta services. Detlef mentioned one, Metanorm. We have also web services, API for solar forecasting. Solar is only part of Metatest, about 10%. The rest is dealing with wind energy, icing, monitoring, geoinformatics, and so on. The International Energy Agency, it was founded in 1973 in Paris. So it was founded during the oil crisis to detect oil resources and to handling this crisis. It is also historically known to be very positive about the oil resources, but now they changed. Yesterday we heard it also from Simon Müller. They are now very much have a lot of about renewable energies. They have so-called technology collaboration programs since a long time, since the 70s already. It's about international exchange, about the state-of-the-art knowledge. And within these 39 programs, 3 are dealing with solar. One is the solar heating and cooling program, one is the PV power systems program, and one is solar PACES, solar chemistry and concentrating solar power. All 3 are linked to the work we are now presenting, but the main implementing agreement or program is the PVPS program. The last task about solar energy was the task 36 and 46. It went on the last 10 years, led by Dave Rennie from NREL and ICES. Here you see a solar resource handbook. It will be updated soon. Let's say end of this year, there will be a new handbook out from NREL. We included some benchmarks, satellite resources, solar forecasts. We made benchmarks. And I will show you also some examples of modeling. So we, for example, made a definition of the circumsolar radiation of the DNI. And we showed how to include ground measurements with satellite data and model-derived data. One result was, for example, a benchmark for German locations. It included the forecast, day-ahead forecast, hourly data. It shows the RMSE as area. Left you see the single points. It was 18 points for 1 year benchmarked. Right you see the average. What is obvious, so if you are looking at the average, the area is half. So there is a lot of area which is smoothing out. You see also a lot of different models, and the lowest line, it includes a multi-model approach, and the red line, which is very low at the first hour, it includes MOS, model output statistics, based on ongoing current data of the synoptical stations. So taking into account ongoing measurements, of course, enhances the results for the first few hours. And then you see also the area level is quite high. It's about 40%, which can be reached, 30% for the intraday. If you average it out over a large area, you get half of the values. But it's possible to go lower, but it will be not possible to go to 0 or to because it will never be possible to forecast the exact position of a cloud 24 hours in front of it. As remarked before, it included the point forecasts. the best model was including different models from German Weather Service, IFS from ECMWF, and satellite cloud motion vectors, and the second best included this GFS MOST. Generally, the higher regional models like HERLAM and COSMO and WRF, they show higher uncertainty values. What we didn't benchmark yet were newer statistical models like support vector machines or ANNs. This will come in the next few years. Just to give our method, which we benchmarked, it included at this time the GFS and then multiple linear regressions, MOS, a very simple one. It is updated hourly. At this time, we included only 3 sites in India. At the moment, we have a multi-model MOS, including ECMWF model, and also for India, we updated it quite largely. One other important outcome of this last task was a study about how the variability is smoothed out over the regions. That's not exactly forecasting, but we talked about flexibility yesterday, and it's very important to understand this smoothing out. It depends on the time, and it depends on the space. We developed a very easy function to model this. So very much the important parameter is the cloud speed. You can measure this, or you can look at the speed at, for example, 3 kilometers altitude. That's the main altitude of the clouds. And so, like with the cloud speed, you can model how fast it is smoothed out. Following these models, for example, area of India wouldn't see any variations below 3 hours. Even it's more in the range of 1 day, the variations which a system within whole India would see. So the larger the region, the easier is the integration. You see here also 2 reports where the models are described exactly. So why a new task? So the installations get bigger and bigger. They get in new areas like India and China, where the climate isn't well known. Aerosols are more uncertain. We get also let's say in Europe, we have some areas with very high penetration. There we have other issues, and the 2 things we will look at in the next few years in detail. Who is part of it? At the moment we have about 20 countries. You see it. India isn't part of it yet. It can be, so I'm happy to have some contacts also with Indian forecasters. India is now part of IEA and also PVPS. We want to have really a global view on the system. Up to now, it was more a view of Europe, USA, and Australia. But for the new task, we could also gain now Chile and South Africa. Here are the partners. At the moment, there are 51 institutions taking part. That's quite big for an IEA task. Normally, it's in the range of 20. But there are a lot of universities, med services, and data providers who want to take part. We want to have partners, active partners, taking part in these benchmarks, bringing forward their knowledge and exchanging it. And we are also happy to have, if we could have some Indian partners, of course. This new task will include resources, so it's not only about forecasts, it's resources like satellite data, like numerical weather prediction models, like satellite-based methods, uncertainty estimations of them, and the benchmarking framework. We want to make new benchmarks and looking for ground data, high-quality ground data. Then the other thing is the bankability. That's more the user view on the whole system. So we are going to look at the quality and the format of the data, how to merge NVP with ground data, for example, looking again on the spatiotemporal high variability like before, but perhaps this time also in 1 second time resolution. We are looking at the long-term interannual variability and also at the products which the users need. One part which is looked at, for example, are the metrics, how forecasts are compared. Up to now, it's mostly RMSE, so the root mean square error. There was a really nice presentation at the WEMC conference and also in this paper I have in the solar energy. The left and the right, they show the forecast the same RMSE, but you see at the right it's leveled out, it's smoothed, and at the left time it includes the variations but slightly at the wrong time, and you get a double penalty if you're slightly delayed or before. And from a point of view of meteorology, the left would be much better, but from the point of the RMSE, both are the same. And so like this, he suggested to make more like this spider graphs, to have a multiple analysis of this, and this TDM, TDI, these are a lot of new words, very complicated. It's more the distribution and distortion effects of the time lags he analyzed. That's not the end of the discussion. But we have to be sure that we go more into details, because RMSE is perhaps good for energy market, but it is not a good measure, for example, for grid integration, because there are other aspects like these time lags which are important, and also the distribution and variation which is needed for some of the user groups. Subtask 3 is dealing with forecasting. Here we are going to look especially about the regional solar forecasting. What's the value of solar forecasting as well, and also the variability and probabilistic forecasting. At the right you see an example of all sky cameras. Here we plan to make a comparison, a benchmark of them. A lot is going on, a lot of universities, but up to now they haven't been compared yet. Here you see the time horizon of the last 10 years, how they evolved. We got much better with the forecasts. This is an example from Richard Perez, who is also part of the task. You see the NVPs models, and you see the satellite. Of course, it's good to mix them. Satellite is good for the next few hours, NVPs for the next day. It's also good to mix a lot of models as much as possible, so you get to the lowest uncertainty values. What's the value of forecast? Here two examples, one from NREL to the left and one from Richard Perez as well to the right. To the left, they showed how much generation cost savings could be done compared to the reduced uncertainty of the forecast. That can be quite much. Of course, it depends on the size of the system. Here is a region, ICO northeast of the USA. It can go into millions, of course. So investments into better forecasts are worth it. Anyway, right, you see Richard Perez calculated how much the battery cost would be if there would be battery to correct all areas of the forecasts. And that's quite low. It depends also, you see, if you go to a single plant, it's a bit higher, because single plant uncertainty is much higher. If you go to bigger areas, you get values of 200 US dollars per kilowatt, which is quite low to correct all the uncertainties of the forecasts. We are going also to the probabilistic forecast. For utilities, it's said it's difficult to handle, but actually, as I said, it's never possible to calculate the position of a cloud in the next day. So a probability density is really the right answer from side of meteorology. Here is an example from analog model from Fraunhofer, from Elke Lorenz, and also NCAR works on it quite much. We will show how to make this kind of models, what are the ideal settings for it, how many stations and how much time should be taken into account as an example. Region upscaling is another issue. Normally a DSO, a TSO needs the value for the whole region. And up to now, everybody does it on his way. There is no, but no method is fixed. There is a brute force method, just using every installation and then summing them up. Others are taking just examples. The other difficulty is that normally you don't know where the stations are and how much, what is the inclination of them. So there is a lot of uncertainty. coupled to this, but it's quite important to model the whole areas, and we want to go into the details of it and give some advice how to do it and what are the linked uncertainty values to them. Here also two papers which has already been published about this question, but we will go into this in the next few years more into detail. Dissemination is also an important part, also being here is part of it. Of course, we will have newsletters, we go to the conferences, journal papers. We'll want to make some webinars also, and workshops, of course. And report at the end will be also one part, but this is not in the center of the work. So to come to the take-home messages, the task 16 is about solar resources and forecasts for solar applications. It's a kind of a trust machine for solar resources, so it gives benchmarks, independent benchmarks, because the individual producer, they always say their forecasts are perfect, and only a benchmark with other products, independent at the same time and place, gives you good values. We will give many guidelines about measurement, forecast, and benchmarks, as said before. We will show which kind of, we could already show that this multi-model statistical enhanced models are the best values or the models which you can get at the moment. You have to take attention about the metrics, the time periods, and the location of the benchmarks. This is very difficult because in the desert it will be always a little bit easier than in a very cloudy conditions like UK. And the best, one of the best overviews available at the moment is this renewable energy forecasting book, which has been published this summer. There you can also gain a lot of information at the moment. Okay, and thank you for your attention.